Hearty welcome to the answers to questions for revision, class 12 mathematics. At this video, 15 questions from linear programming and probability comprising MCQ, assertion and reasoning, very short answer, long answer, and case study questions is compiled and answers are discussed. Question number 1. You have been given the graph of the inequality 2x plus 3y greater than 6. You have to visualize it and you have to check out which will be the correct option. Now this is you can visualize it 2x plus 3y, it passes through what point and it is greater than 6. But remember, this is a strict inequality. Therefore, you have to check out which option can be correct. It is a half plane that contains the origin? No. Half plane that neither contains the origin nor the points is the correct answer. But whole xy plane cannot be the correct answer and entire xy plane cannot be the correct answer because a inequality will always divide the plane into two half planes. Well, now therefore 0 does not satisfy and the inequality divides into two half planes. Therefore, the inequality does not contain the points on the line. Therefore, option B is the correct option. The feasible solution we have to find out, and we have to find out where the minimum of z occurs at what points. Very simple. You have to form the table. The table is formed and I am checking out that the minimum value occurs at 0, minus 8 and minimum value is minus 32. Therefore, the option is B. Simple question. Question number 3. A die is thrown and a card is selected. The probability of getting an even number and a spade. Whenever these type of questions are coming, we have to just be very clear whether this is coming under conditional probability or they are all independent events. Let us check. A is equal to event of getting a even number and B is event of getting a spade. And probability of A I can find, probability of B I can find by making use of the formula. Then they are independent. We have to get the probability of even number and spade card A intersection B, probability of A into probability of B. Therefore, the answer is 1 by 8. Question number 4. P of A given B and P of A and P of B is given. You have to find P of B given A. Just to recollect the formula of A given B. P of A intersection B by P of B and P of B given A is P of A intersection B by P of A. For both of them are connected by P of A intersection B, where we will find P of A intersection B by making use of the given first three conditions. For I am getting P of A intersection B as 0.24. Go back to the formula P given A. We have to substitute these values now. You got the answer as 0.6. Question number 5. In a college, 30% file in physics, 20% in maths, 7% in both. Over P of A given, B given, P of A intersection B given. One student is selected at random. Probability that she files in physics if she filed in maths. Condition probability. Over P of A is given, B is given. Event of filing in physics, event of filing in maths. P of A is 30 by 100. P of B is 25 by 100. P of A intersection B is 10 by 100. Now let us check what is given. Files in physics, filed in maths. Therefore, P of A given B is asked. Be careful with that. P of A intersection B is P of 10 by 100 and P of B is 25 by 100. Substitute it. You will get the value as 2 by 5. You should be very careful whether A given B is asked or B given A is asked. Be careful in the question. Question number 6. Assertion is given. Reason is given. Two dice are thrown. Probability of getting an odd number on first and multiple of 3 on the second is 1 by 6. And it is given that P of A plus P of A dash is equal to 1. Let us see. Let us check the assertion. For the experiment of throwing two dice, total cases 36. A event of getting odd number on the first and multiple of 3 on the second. And A is this one. And P of A is 1 by 6. And assertion is true. Simple way. Getting odd number on the first and multiple of 3 on the second. Assertion is true. Let's check the reason. Reason is also true. But this reason is not used to prove the assertion. Therefore, option is B. Let's go to question number 7. P of A is given, P of B is given, P of A union B is given. You have to find P of A dash given B dash. Okay, let us go back to the given conditions. Assertion. A is given, P of B is given and P of A union B is given. And you know the formula for P of A dash given B dash. It is P of A dash intersection B dash divided by P of B dash. Now, how to get P of A dash intersection B dash using De Morgan law? It is A union B the whole dash, which is nothing but 1 minus P of A union B, and P of B dash is 1 minus P of B. For I am substituting those values, I am getting it as 2 by 3. Therefore, assertion is true. Now, the reason is nothing but the formula of De Morgan law. Therefore, reason is also true, and it is used over here to prove the assertion. Therefore, option is A. Let us go to question number 8. You have to solve the linear programming problem. And before you go to that, be careful. You just get the points and check whether the given line contains the origin or not, given region contains the origin or not. Then you go to the graph sheet. Let us go to the first line. Points I am getting it as tan 0, 0, 5, and you can get the points in any way. I am putting x is equal to 0, get the value of y, put y is equal to 0, get the value of x. So one shortcut where we will get the points on x-axis and y-axis and join them. Origin is not included because it is greater than or equal to 10. Origin is not satisfying. Once again, the second constraint 6, 0, 0, 6, origin not included. Third line, points are 1, 5 and 0, 8, origin not included. Here when I put y is equal to 0, I am getting x is equal to 8 by 3. Therefore, I am avoiding it. Therefore, I am putting x is equal to y is equal to 5 and get the value of x. Well, now the first constraint I am drawing it over here, and origin is not included, therefore it is going up. Second line I am drawing, origin not included, it is also going up. Third line I am drawing, origin not included, it is going up. Now this is the unbounded region you are getting, A, B, C, D. The feasible region is the unbounded region, and all of you know that even though it is unbounded region, optimal value lies only in the corner points. Where I am substituting it now, the corner points now, I am showing it in the form of a table. In the table, I am seeing that the minimum value is at 2, 4 and the minimum value is 52. Now, you have to consider that less than 52 and any point when you take in the region, it is not satisfied by that 6x plus 10y less than 52. Therefore, this is the minimum value. Okay, now whenever it is a minimum value, you have to check whether is there any other value in the feasible region which is minimum than this. But it is very simple. It is only a cross checking it itself. I think I am taking a point 10, 2. I am just taking a point in that feasible region, unbounded feasible region, and then checking it. Go to question number 9. Again, solving a linear programming problem graphically. Once again, I am getting the first line. I am getting the points, origin included. Second point, once again, origin excluded. And third constraint, points are found and origin excluded. Let us draw the diagram now. This is the point. Now, before you go further, check out what is the scale you have to take on x-axis and y-axis. I have taken 10, 20, 30 on the x and y-axis. Okay, origin included, coming down, and origin excluded is going up. Again, origin excluded, it is also going up. Now this is the feasible region you are getting in the form of ABCD, a quadrilateral, and I am showing you the point of intersection, and you are getting the point of intersection directly from the diagram itself. Otherwise you solve it and then get it. The minimum value of Z is 240 at 6, 12. Now question number 10, the probability distribution is given, find the mean. Now, you know the formula for mean, it is sigma pi xi, but for that we have to first find the value of k. How to get the value of k? You know that the formula that the probability distribution, sum of the probability is equal to 1. Where I am getting the value of k, k is equal to 1. Now I am defining the distribution now. 1 by 2, 1 by 3, 1 by 6 are the probabilities. Now you find the value of the mean now. It is 5 by 3. Question number 11. A bag contains 4 yellow and 5 red ball. Another bag contains 6 and 3. One ball is transferred and then a ball is drawn. Find the probability that the ball drawn is yellow. There are two experiments, transferring a ball and selecting a ball. Let us go to the first experiment, transferring a ball from first to second bag. Which ball can be transferred? Yellow transferred, or even B, non-yellow is transferred. That is a red ball. Suppose if there are 3 colors, then you can directly take it as non-yellow. Now P of A is 4 by 9. All of you know P of B is 5 by 9. Simple. Now we have to find drawing a ball from the second bag. Now, when you draw a ball from the second bag, it will be a conditional probability. Number one, E is the event of selecting a yellow ball from the second bag. P of E is either you can select after a yellow ball is transferred or a red ball is transferred. So, this is P of A into P of E given A plus P of B into P of E given B. What is the meaning? Probability of selecting yellow ball after a yellow ball is transferred plus probability of B into probability of selecting a yellow ball after a red ball is transferred. Okay. Well, let us find it now. Directly go to substitute the values now. 4 by 9 into 7 by 10. Why it is 7 by 10? Because a yellow ball is being transferred over there. Therefore, it is 7 by 10. There were 6 yellow ball. Now it will become 7. Total ball will become 10. Again, how this 6 by 10 came? Because there were 6 yellow ball. Only a non-yellow is transferred. Therefore, it will be 6 only. But total will be 10. Because 9 plus 1 is 10. Therefore, the answer is 29 by 45. Let's go to question number 12. Yes, A speaks to 60% of the cases, B 90%. In what percentage they like to contradict? E is the event that A is speaking the truth, and E complement is the event that A is not speaking the truth. P of A is 60% and P of E complement will be 4 by 10. If be the event that B is speaking the truth, as usual, it is given 90%, for 9 by 10. Its complement will be 1 by 10. A and B will contradict each other if first is telling the truth and B is telling the lie, and or A is telling a lie and B telling the truth. How to put it in form of notation? E and F complement or E complement and F. Or is coming, therefore union will come. And is coming, therefore intersection will come. Now these are mutually exclusive, therefore you have to add them. And we have to simply multiply because E and F complement are independent. Substitute the values now, you will get it as 42%. Go to question number 13. Hockey match. A and B scored same number of goals. Referee throw a die and decide which teams wins. The captain of the team we were asked to start respective probabilities of winning the match, and we have to find whether the decision of the referee is fair or not. E is the event that captain of A getting the number 6. That is very clearly that getting a 6 first will be declared winner. And E complement is the event that does not get the number 6. P of E is 1 by 6, all of you know. E complement is 5 by 6. F be the event that getting the number 6. Therefore, F complement, P of F is 1 by 6 and P of F complement is 5 by 6. Now what will happen now? If the captain A tosses the coin first, then get the number 6 and win. Therefore, either he tosses it E, or either he is not getting, then B is not getting, then he will get a chance. Therefore, E complement F complement E are first, both of them are getting 2 chances. First he is not getting 6, B is not getting 6, again A is not getting 6, B is not getting 6, again A got 6. Like that, this will be going on. Therefore, it will be union. R is coming. Therefore, union I am putting. Now, these events are mutually exclusive. Therefore, you have to add them. Now, the events are independent. Therefore, you have to multiply them. Now, you got all the values now. 1 by 6 plus 5 by 6 into 5 by 6 into 1 by 6 plus 5 by 6 into 5 by 6 into 5 by 6 into 5 by 6 into 1 by 6 and so on. Now, in all of them, I can take 1 by 6 outside. Now, I am getting an infinite geometric progression where A is equal to 1 and R is equal to 5 by 6 the whole square. Now, you have seen the formula for sum of infinite series of geometric. It will be A by 1 minus R. For I am substituting now. For it is 1 by 6 into 1 divided by 1 minus 25 by 36. Therefore, the answer is 6 by 11. Therefore, if this is 6 by 11, then what will be the probability of the team B winning? It is 5 by 11. Very clearly, it is clear that the team which start the game of tossing the die has more chances. Therefore, the decision of deciding the winner by tossing a die is not fair because both are not getting the same opportunity. If it is 1 by 2, 1 by 2, then we can tell that okay. But it is 6 by 11 and 5 by 11. Good. Question number 14. A scientist has to make a decision on each of the 2 independent events. The probability of error is given and find the probability that will make a correct decision in both the events and only one event. Now let A is the event that scientists make a correct decision, and B is the event that it makes a correct decision on event 2. Now P of A complement is given. Be careful. Error given. Therefore P of B complement is also given. Therefore P of A and P of B I am finding, and keep it ready. Therefore these are the values now. Now make correct decision on both the events. What is the meaning? He will get correct decision in first also and second also. A intersection B. They are independent. Therefore you have to multiply. Therefore it is 0.931. Make correct decision on exactly one event. What is the meaning? He make a decision in A, not in B, or not in A and in B. Therefore these are mutually exclusive. Therefore we can add them. They are independent. Therefore we are multiplying. Therefore the answer is 0.068. Question number 15. A survey was conducted. Height of the boys and girls were compared. 4% of boys and 1% of the girls are taller and than 1.75 meters. 60% of the school students are girls. A student is selected from the school and found to be taller. Find the probability that selected student is a boy. First experiment is selecting a student of the school. This is coming under Bayes theorem. And A is the event that selected a student is a boy and it is 40%. B is selecting a student is a girl, 60%. We are keeping the values ready. Now let us go to the second experiment. Observing that the height of the student. F is the event of observing the height of the student is more than 1.75. It is first we will find what is E given A. That is the student whose height is more than 1.75 meter is a boy. It is given that 4%, 4 by 100. P of E given B, student whose height is more than 1.75 is a girl, but it is 1 by 100. For all the values are known to you. Now we have to go for the Bayes theorem. Probability that selected student whose height is more than 1.75 is a boy. It is A given E. You know the formula. Substitute the values over there. You will get the answer as 8 by 11. Let us go to the second question. That it says girl. E probability that selected student whose height is more than 1.75 is a girl. It is B given E. You know the formula. Now substitute in the formula. It is 3 by 11. Anyway, the first one is 8 by 11. The second one should be 3 by 11. Where you can get it directly also. Because both of them are exhaustive events. For addition should be 1. Okay. Thank you friends. All the best.